Hi, year 13s, welcome back. In this video, let's talk about the questions that I asked you guys to do as homework, just some reviews before the exam. So one of the questions is the following. So the integral of sine 2 theta over 1 plus cos theta, they want us to show with limits that turns into 2 minus 2 ln 2. What sort of strategies should we use for this question? You could, again, run through this checklist, which is starting from the fundamental results from 11.1, which are the following 9, and if you could apply it. If you cannot, try and rewrite this expression and see if you can apply these formulas again. If the answer is still no, then you just carry on and see if you can solve it by either using integration by parts, reverse chain rule, or integration by substitution. And in this question, we should be using a substitution. So let's try the question. So the substitution will be the bottom, which is u equals 1 plus cos theta. So you could just differentiate that, which is du by d theta, gives you minus sine theta. And you like to make d theta the subject, so you could substitute it into the to d theta, and then you could substitute u into the expression 2, which is just the bottom. So let's try that. So we have the integral of originally the limits for theta, pi over 2 and 0 will now change in terms of u. So you could substitute pi over 2 into it and find the value. So for the first one, you'll get 1 plus cos pi over 2, that gives you 1, and 1 plus cos 0, that gives you 2. So you could almost immediately in the second step and change everything. So change the limits, rewrite the obvious expressions in terms of u, and then change the d theta into du. So you will have so you will just change the corresponding values. So the integral from now 1 and 2 in the same position. So sine 2 theta over u multiplied by du over minus sine theta. And then you could try to extinguish all the sine thetas or all the thetas you have in the expression. So let's try and rewrite sine 2 theta, which is 2 sine theta cos theta divided by u multiplied by minus sine theta du. And then you could just simplify that, and gives you minus 2 cos theta over u du. And then you could swap the limits, and that will give you from 1 to 2 of 2 cos theta over u. And then now we could rewrite this 2 cos theta in terms of u, since u is 1 plus cos theta. So you could make cos theta the subject by rearranging it and put it back in, and then you will have a nice little integral to solve. So you have the integral from 1 to 2 of 2 multiplied by u minus 1 over u du, and then you could separate it into 2 fractions, and then you'll probably get the answer. But let's carry on. So you could cross it out to 2 minus 1 over u, integrate. You'll have 2u minus ln u. Now substitute the limits into it, and you'll have 4 minus ln 2 minus bracket 2 minus 0. So you have 4 minus ln 2 minus 2, which is 2 minus ln 2, as required. What's wrong? What's a 2 there? Oh yeah, I made a mistake here. Because when I expand this, that will give me 2. My bad. So that should be 2 ln u So that's why there's a 2 there. My bad. So that should be a 2 there. So I made a little mistake right there. Okay, but in generally speaking, the way of solving it should be fine. So remember, so when you need to do a substitution, so you change the expression in terms of u straight away, change the limits if given, and also make d theta as a subject based on your expression after differentiation. So that's the first question. And now the second one. So we are given a mint made of a sphere with the dimension of 5 millimeter radius is now available, and then after 4 minutes the radius is turned into 3 millimeter, and then it's a model where we will talk about the rate of change. So because this is a rate of decrease of the radius, that is almost certain that we could write based on this expression, we could write dr, the rate of radius dr over dt, and then it has to be something negative. Okay? And since they say that the rate of decrease is inversely proportional to the square of the radius, that will mean dr by dt is going to be minus k over r squared. So let me just highlight the information. So inversely proportional to the square of radius is this part. And now for part A, they want us to find the equation linking the radius of the min and the time. When that happens, that means they want you to solve the differential equation. In this case, we'll start from the information provided, dr by dt is minus k over r squared, and we'll separate variables. So we'll keep the r's on the left, and we'll chuck all the t's on the right, if any. So we have minus k over r squared dt firstly, and you could move the r squared to the other side. And then this is where you successfully separate the variables, and then you could integrate. So let me carry on here. So integrate both sides, you'll get a third r cubed equals to minus k times t, and you just need to add c on one side. And then not usually in this moment, you'll write to find all the missing constant, which you could find it with the information at the start. So the first statement, they told you that r is 5 when t is 0, and then r is 3 when t is 4. So that's why you could just use it and then find the value of r of k and c. So let's quickly do that. So we have a third 5 cubed equals minus k bracket 0 plus c. That means c will be 125 over 3. And then you can find k from there as well, which is a third times 3 cubed equals minus k multiplied by 4 plus 125 over 3. Rearrange it, you have 4k as 125 minus 3 cubed over 3. So you could put this number into the calculator and find it. So you have 49 over 6. And then you have you could put these back in, and then you have an equation linking the radius of the min and the time. A third r cubed equals to minus 49 over 6t plus 125 over 3. And then just define the variables needed. So r is a radius in millimeter, whereas the time, in minutes, which is represented with the letter T. With that, you could go on to part B. So find the total time taken for the min to completely dissolve. So you would like to utilize the formula that you have with R linking T and solve the question. So they tell you that it's totally dissolved. So that means it is gone completely. So you could assume that R will be 0 and then solve for t. So let's do that. So you will have R equals to 0. So a third bracket 0 cubed equals minus 0.9 over 6. T plus 125 over 3. So you'll have 0.9 over 6t equals 125 over 3. And you solve for t. So you have 125 over 3 times 6 divided by 49. So you have something like 5.102 minutes. And they want us to give your answer in minutes and the second to the nearest second. So we will have 5 minutes and additional 0.1 minute ish. And then since in 1 minute there are 60 seconds, so you could just use the conversion to find out that in 0.102 minutes there will be that is 60 seconds. So you could just find the how many seconds worth in 0.102 seconds. So you have 6.12 seconds, which is just technically 6 seconds. So you could just say that the time that we have is 5 minutes with 6 seconds. So that will be the answer for part B. And that is it for you for part A and B. And that will be the end of this video. And I hope you find this useful. Thank you.